Hi, kids. Hi, I'm going to talk to you a little bit about radioactive decay. And you might think, well, that seems like a chemistry thing. And it is a chemistry thing. But remember, physics is the basis behind what all sciences are based. So we do have to understand a little bit for this class about radioactive decay. So remember, this is talking about where my nucleus breaks apart, and somehow it goes from an excited state to a less excited state. And why does it happen? Most of the time it happens because if your nucleus gets too big, it becomes unstable and part of it breaks apart. So let's just go through the three basic things. And for this class, it's super basic, super easy as far as if you understand. So the first one is called alpha decay. Okay, except I should probably spell alpha right. Alpha decay. That's what it's called. It's called alpha decay. And so I start with a nucleus, and my nucleus is too big, so it becomes unstable. So let's say this nucleus is some random nucleus where my atomic number is Z. Remember your atomic number, and please make sure you understand this. If you don't, write it down. This is the number of protons you have. This is your atomic mass. The atomic mass is the number of protons plus the number of neutrons. So if you add up the protons and neutrons, that's what you get. Atomic number, atomic mass, okay? And what happens is this is unstable. This nucleus is unstable, so it literally breaks apart. And what comes out of it? Well, a helium nucleus. So this is really this because there are 4 particles. There's 2 protons, 2 neutrons, and it's 2 because there's 2 protons, because protons, and then this is the number of neutrons, which is protons plus. So then, if this is what happens, well, hey, if this breaks away, what is the top going to be? Yeah, it's just that easy. It's going to be, so my new thing is going to be A minus 4, and this would be whatever Z minus 2 is. And if you wanted to know what that is, you have to get a periodic table and look it up. So like you would start with some element, and then it would decay, and then you get some new element, okay? But when this happens, okay, there's also going to be energy that's released. Sometimes they call this a neutrino. Sometimes they just say it's just some extra energy, but there is going to be some energy that's released. So there you go. So again, don't make it any harder than this. Just make sure this top has to add up. Whatever this number is, this is going to be 4. This is going to be A minus 4. Alpha particles, sometimes you'll see it written as just that because that's the symbol for alpha. And then same thing on the bottom. Okay? So that's the first type of decay. Second type of decay is this. Okay? A neutron. Remember, a neutron is made up of a down and up and another down quark because it's a dud. But it can decay into a proton plus an electron plus some energy. Well, this electron is called a beta particle. And sometimes you'll see it with a little negative to show you that it is a negative. If they put a positive there, then it's called a positron. But it's just like an electron with a positive charge. So if you take a look, so in this case, hey, I have a neutron, and one of my neutrons gets converted to a proton. So, well then, if this is my starting element, and one of my neutrons get converted to a proton, well, then my new element, which I'll call X prime, is, do you see how the atomic mass is going to stay the same? Hopefully that makes sense, because one of those neutrons gets converted. But if one of the neutrons gets converted, then this has to go up. So this would be Z plus 1. Well, if I have my beta particle, so which is really just an electron, which is, as far as the mass goes, it has hardly any mass compared to the stuff in the nucleus. And then if you look, do you see how, again, this has to add up? A equals A plus 0. Z equals Z plus 1 plus negative 1. Okay? And then you'd get some energy. Okay? If they wrote it something like this, if they said, hey, you had they said this was the case. So if they said plus, whereas a positron, well, that's telling you your element or your fundamental particle here. I don't know the symbol for a positron. I'm going to call it E, like positive. And then this would be 0, and this would be positive 1. Well, if that's positive 1, well, that means that this would be Z minus 1, and this would still be A, which means this is more going to be like your antiparticle stuff. That means that one of these, a neutron turned into an antiproton, which has a negative charge, and then a positron, okay? But the key is just make sure the stuff adds up and you will get the problem right, okay? They have at least 1 or 2 of these on the AP test every year, and do it right and you'll get it right. And then last thing, which I put in, green because, obviously if you get hit with, gamma rays, you're going to turn green and really strong, you know what I'm saying? But anyway, so typically what's happening here is you have a nucleus that's super excited. If you were to think of your, our energy diagram, our energy wealth, or our energy diagram thing, well, if it was with a nucleus, the size of the energies are going to be way bigger. So if this goes from an excited state to a less excited state, you're going to give off lots of energy, which is going to be your gamma ray, because we know H energy is HF, and if this number is super big, then that number is going to be super big. So there you have it. Bye, kids.